let's now have more developments on the member class. Okay, double click on the member class, and this is the exercise I would like to go over together with you. If you either you try but you got stuck, or you haven't tried, either way, I'm gonna go over the solution together with you to make sure you're okay. However, before doing that, I would like to talk about two small items. One is about anonymous objects, basically objects without any names, and also overloaded methods, basically methods with distinct with the same name but distinct lists of parameters. So these are the two items I would like to speak about first. What about first of all about anonymous objects? It's actually a very easy idea. So let me just go to the JUnit test over here. You can see, for example, if you look at this line over here, we talk about in order to visualize what's really happening when you create an object, you want to split it into three parts. Part number one, you're basically allocating some space in the memory and create an object of type facility. And then you will simply call the constructor to initialize spinning class 2.5 and 1. So that's the first step. And the first step basically will only just create an object, of course, with an allocated address. However, the address has not been stored anywhere just yet. And then it will be these two steps that will actually declare the variable f1, which can store any address of type facility. And then this particular variable assignment operation is going to store the address of this particular object into the variable f1 over here, right? So the same explanation will apply to any object creation that we have spoken about. And what's really anonymous objects? And let me just illustrate to you, is a very simple idea. So what I would do is I'm simply just going to maybe copy this test over here, and let me just rename this to be maybe test 1 over here. Okay, and then let me maximize it and then paste it. And I'm going to say maybe test number 2 over here. And this one here, I'm going to say, rather than giving names to f1, f2, f3 over here, right? Rather than doing that, I would like to add facility over here. So what's really being expected over here? Let's remind ourselves. If you go back to add facility over here, let me just go back. If you go back to here, let's go to add facility. I think it's mutator method at the end. You can see this add facility method over here. It is expecting some object reference of type facility. So as long as you can give an object reference to it, it will be acceptable. Either it's an object reference that's stored in a variable, you can just pass the variable directly. That's what we did previously. Or you can simply just create an object on the fly, and then the address of that object created on the fly will be passed as arguments. So that's the idea. Let's go back to test member over here. Okay, so now rather than giving a name, I'm gonna write the explanation as a notes for you in just a moment. What we can do is I can simply just copy this expression over here. You can see I'm highlighting it. So just copy this and then paste it over here. This will be just valid syntax, right? You can see it's just the syntax you want to get used to. Conceptually, it's very easy. You can think about this part over here. This is just an object that's created on the fly without its address being stored in any variable. Okay, passing an objects, passing the address of an object being created on the fly, dynamic on the fly. Okay, without first storing its address in a variable, right? So previously what we did was we're going to run this particular statement over here, and then we simply pass f1 because f1 stores this object's reference, this address. However, now we don't do it, we simply just do this directly. Okay, what would be the disadvantage? The disadvantage would be, so now in order to refer to this particular object over here, you cannot use f1 anymore because f1 is simply not there, right? So that's something I will discuss later about how you can get access to the objects in the array for the facility. That's something I'll talk about in the later video. But for now, you'll learn about the syntax and about what it means. Okay, let me just cut this explanation over here and put it here. Okay, it will be very important for you to know how to use anonymous objects. It's very convenient notation. Whenever you simply just want to pass the objects directly without storing its address first in some other variable. So you can just use anonymous objects, meaning that it's objects without any name. Okay, we can do something similar for F2. Rather than storing this object's address into F2 first, I can pass the objects directly. All right, similarly, right? You can see the idea. And then I can also copy this line over here and over here. Okay, let me say this. Cons of anonymous objects. Okay, let me just fix the typo over here. Okay, we cannot use variables such as F1, F2, F3 to refer to the objects. Instead, we need to get access to the underlying private facilities array. But at the moment, we actually don't have that just yet, but we will do that later in the video. So you can see at the moment in the member class over here, you can see the facilities array is actually private over here. So we simply just cannot say Hyang.facilities. That wouldn't be allowed. Well, let me just show you quickly. So that might be something that's worth showing. So instead, okay, for example, if I try Hyang over here, if I say dot, you will actually see that all the applicable methods or none of the attributes will be applicable to be called upon Hyang because all the attributes have been declared as private. I can try. So over here, if I simply spell facilities, for example, if I do that, if I move my cursor over, the file member is not visible, right? You can see facility is simply not visible. So this is why for every private attributes, if you wish to really make it accessible to other classes, it's not the way to go by simply making the attribute public. It's not the way to go. Instead, for example, remember in order to make trainer accessible, we simply declare get trainer somewhere. You can see the public accessor method. So that's something I mentioned previously already. I just want to reinforce. All right, let me go back here and then just keep this in mind. Let me just make a note over here. This is invalid because facility is private and thus invisible. All right, so keeping this in mind. And then, okay, that's about anonymous objects. So hopefully now you're comfortable with it. You can also find also examples in either the lecture and also in the lab, lab number 6, J-unit test cases. You can see examples for anonymous objects. Okay, all right. Let's now move on to the second item I would like to speak about, which is about overloaded methods. Let me just take this one for example. Let's say let me go to the public add facility over here. So whenever we talk about overloaded method, okay, let me just make a note over here. Overloaded method. Basically, they are methods with the same name, but distinguished by their lists of parameter types. Okay, it's really useful ideas in Java. So for example, let's say I want to define another method here, which is simply just called add facility. I will be able to do it provided that I can simply give a different parameter type over here. You can see here I'm taking just the facility objects as the single parameter type, but I can try to make it different. Okay, let me show it to you. Let me so I will do. So rather than passing the facility objects directly, I can pass all the information that's needed in order for me to create a facility objects internally. That's what I can do. Let me just do this over here. And oh, you know what? Let me just type from scratch. I think that'll be better. So I can say public void add facility. And what information will be needed for me to create a new facility? Let's take a look. Let me go back to facility over here. You can see I need the name and the price and the units. I can simply just copy these parameters, just easier. Okay, let me just copy them. I'm just showing you example, right, about overloaded method. Let me go back to member over here. I can simply put these. So in order for me, you can see this is one list of a single parameter. And this is a list of 3 parameters. They're definitely distinguishable by the distinct lists over here. All right. So now what should we do? Well, in order to really add into facilities array, we must have a facility objects, basically, right? You can see here f is simply the parameter facility objects, but now the parameter is simply name, string, double, and int. So what should we do? So that means we need one extra step to really create some local variable object first, and then store the local variable objects into the facilities array. That's what we should do. Okay, let me show it to you. Let me show you the slightly reverse way over here. So I can say here, let's create a local variable. I can say facility and then f. Right? You can think about this f is somehow similar to the f over here. Okay, and then we'll say new facility and then name and also price and then units. You can see in this case over here, I'm using the parameter f in such a way that I can simply store the reference that's stored in f directly into the array slot, like how I trace it in the previous video. But now in this case, what I do is I do one extra step by saying I'm going to use the parameter over here to actually create a new facility objects, and then I can add this particular local variable into the facilities array. Okay, so what you should really notice is the f over here in the previous version is actually referring to the parameter, but the f over here is referring to the local variable I'm creating, right? Just notice that. All right, what should I do over here? I can say, basically, I can simply copy these 2 lines. That's all I need to do. However, well, we want to really minimize code duplicate as much as possible. So why don't we say, rather than repeating these 2 lines, we can simply call the helper method. Call this method as a helper method. Okay. So now, whenever you want to refer, remember, if you want to refer to the attributes at the class level, you can use this. Similarly, if you want to call the methods within this current class, you can also use this. You can say this dot add facility and then f. So this will just work. You can see over here, right? You can see now we got f over here created as a local variable, and then we simply say here without this it would be okay. If you simply say f facility, you can see if I move my cursor over, it's still referring to this f facility method over here. However, in order for you to trace, I'll leave that as an exercise for you. So when you try to trace this particular method over here, so this should also be replaced by any context objects you're calling the method on, right? So that'll be beneficial if you put it here for clarity. All right, let's now test very quickly about this particular overloaded method. Okay, let me go back to my test over here. Let me, so this part here is about anonymous objects over here, right? And then, you know what? Let me say 1A and also 1B. Let me say this is 1B is okay, okay? So this is how we illustrated anonymous objects. Okay, let's now have another one. Let me just copy 1A. I'm going to have another called 1C. So that's really to really call the overloaded version for F facility. So let me say 1C over here. All right. So now what I will do is I'm going to just comment these 3 lines. Okay. Command or control /. So that now add facility, rather than calling the version that's expecting a facility object, I'm going to call this particular version over here. Sorry, not this one. If I go back to the member, I want to call this particular version over here with the name, price, and units. Let me go back here. So now rather than calling F1, I can simply say I just need to pass in the information that's sufficient for the method internally to create a local variable facility object, and then it will do everything else by calling the first version. Okay, like this. Right? You can see this still compile, right? So you can see this at facility is the overloaded method. Overloaded version. Okay, so now, so this one C here, we are trying to illustrate overloaded methods. All right, similarly, we're also going to copy for F2, rather than passing a single object, we're passing the information that's necessary to create the object internally. Similarly, also for locker. Oops, just like that. All right, let's now run the JUnit tests over here, and we still get a green bar. All right. So in this video here, I'm just illustrate two simple concepts to you. Let me recap very quickly. Number one is about anonymous objects, which means objects without any name. So you can see I'm calling the first version for at facility over here, for example, and then rather than simply give the name of a variable that stores some address of the objects, I will simply pass the objects directly. And you really want to know what's really the disadvantage for this. You just cannot use F1, F2, F3 anymore. You have to somehow get access to the private facilities array, but we'll cover that in a later video. Item number 2 that we spoke about is about overloaded methods. So if you go back to the member class, you can see we are having two versions of the methods with the same name. You can see at facility and also at facility over here. But they have, even though they have the same name, but they can be distinguished by distinct lists of parameters. You can see parameter of facility and also parameter of string followed by double followed by integer. So it's definitely allowed. It's called overloading for methods. All right. So that's about what I want to speak about briefly in this video here, and then in the next video I will for sure walk you through about the solution for get payment due method.